Okay, so let's start with question number 1. And this question number 1 came from somebody, Fiza Memon. So what is Fiza trying to say is that how to maintain pressure between 60 to 20 and the velocity of 1.5 meters per second of water system model. Please let me know, I am really confused. So that is our first question, and it comes from Fiza Memon. Fiza Memon, let me tell you one thing. Confusion is the first step towards mastery, especially when you are learning. Actually, that's the joke, don't take it seriously. Let me start by telling you this. We really need to understand the basics before I even jump to your question. When water is in the closed conduit, automatic water is going to experience two kinds of pressure. Number 1, static pressure, and number 2 is residual or dynamic pressure. And when we are talking about static pressure, we are talking about pressure when water is not moving. And static pressure is the function of terrain, is the function of topography. And again, to put it even more simply, static pressure is the function of elevation. Let me put it that way. And as I said, static pressure is only when water is not moving. So for example, you have this as a pipe. So let's say this ink within this pen is water. So if I close here and also I close here, automatically the water within this conduit or within this pipe is not going to move. And this is exactly the moment when we say water is experiencing static pressure. And let me tell you one thing, if you don't know, in most cases, the main causative of pipe burst is static pressure. I don't want to go to that direction because I'll be introducing another topic which is not a good thing. Let me go back to your question. So that is static pressure. As I said, we have two kinds of pressure. Static pressure, of course, we have cleared it already. And the other one is residual pressure. So let's talk about residual pressure a little bit. And from my experience, your question here, what is referring to is residual pressure or dynamic pressure, not static pressure, especially when you are using the software like Ethernet or WaterGems. So when you are talking about residual pressure, you are talking about pressure, especially when water is moving or when water is in motion. Okay, so when water is moving within the closed conduit, that's when you have residual pressure. And not just that, residual pressure is influenced with two things. Of course, elevation might be one of those two things, but the main thing is friction losses. And when we are talking about friction losses, we are talking about two formulas that we normally use to quantify friction losses. And the first formula is Hazen-Williams, and the other formula is Westpac. When you want to increase pressure within a closed conduit, what you need to do is actually to increase pipe diameter. Just take that Hazen-Williams formula, then you will understand one thing, that friction losses is inversely proportional to the diameter. So when you increase the diameter, you actually reduce friction losses. And if you have less friction losses within a closed conduit or within a pipe, automatically what you're going to have is high pressure or high residual pressure. So if you want to achieve, let's say 60 meters of water column, what you need to do is to increase the pipe diameter. So instead of using, let's say 1-inch pipe, just go to 2-inch pipe. So for a given discharge, go to 2-inch pipe instead of 1-inch pipe. So on the other hand, when you want to reduce the residual pressure in your system, what you need to do is to do just one thing. Just reduce the pipe diameter. And when you reduce the pipe diameter, what you're going to achieve is just one thing: higher friction losses in your pipe. And when you have high friction losses in your pipe, automatic pressure or residual pressure or dynamic pressure within that particular pipe will be reduced. So just to put it simply, when you want to reduce the pressure within the pipe, what you need to do is just reduce the pipe, increase the friction losses. After increasing the friction losses, automatic residual pressure is going to be taken care of. Okay, so let's go back to the second part of your question. And it goes like this: how to attain or how to achieve 1.5 meters per second, okay, as velocity. And I'm not going to answer you straight how to achieve 1.5. Instead, what I'm going to do is to give you context so as you understand. Okay, so to give you context so as you understand how to achieve any velocity value in your system. So let's say you have two values, 1.5 and 0.4. The question is how to achieve 0.4 and how to achieve 1.5, how to achieve higher value of velocities and low value of velocity. That's the question now, okay? And it goes like this. Velocity is direct proportional to friction loss, or in other words, friction loss is directly proportional to velocity. So you just take any friction loss formula, as in Williams or Das-Weisbach, you can tell it. So in other words, if you want to have like low velocity value, what you need to have is to make sure that you have low friction losses in your pipe, according to Hazen-Williams or any friction loss formula. And how to achieve small value of friction losses is through one thing, to make sure that you have the large pipe diameter. So that is how to achieve small value of velocity. And how to achieve the higher value of velocity on the other hand. It's quite simple. Again, by using any friction loss formula, you can tell velocity is direct proportional to friction losses. So if you want to achieve high friction losses, or if you want to achieve high velocity value, what you need to do is to make sure that you achieve high friction losses values. And how to do that is actually by reducing pipe diameter. So in summary, if you want to achieve, let's say 0.4 for our case, just increase pipe diameter, reduce pipe friction losses, then you have your low velocity value. But if you want to achieve higher velocity values, just reduce pipe diameter, then accumulate friction losses, and what you're going to achieve is high velocity values. So that's it, Fiza Memon. I hope I tried to answer your question. Let's go back to the other question and see what we have. Okay, so third question came from somebody 3DS Max 35. I don't know if that's the name, but the question goes like this: how to calculate head loss gradient manually, and what's the formula used for it? Thanks in advance, sir. Okay, so what he's trying to ask is that how to calculate head loss gradient manually. Okay, and he wants to know, or he or she wants to know which formula can you use to achieve that. So here we have two things. We have head loss and gradient. Okay, head loss and gradient. So as far as head loss goes, for our case, you can even use Hazen-Williams, or you can even use Das-Weisbach. Then you are going to have major friction losses. Okay, so in a given pipe, you're going to have major friction losses value. And if you have that value, if you want to achieve now head loss gradient, you need to take that value, then you divide it with the total length of your pipe. Okay, so you just take that friction loss value that you have calculated by using any formula, Hazen-Williams or Das-Weisbach, then take that value, divide it by the pipe length. Then you have the head loss gradient. But if you are using software like Ipanet or WaterGems, that can be even simple. But if you want to calculate it manually, then that's how you can do it. Okay, so that's that. I thought this tutorial was going to be very short, but actually I was wrong. And until now, as I consumed so many minutes in this tutorial, but it's worth it. I'll find another time maybe to go through the comments and other questions that I believe I need to go deep on them, or at least to find something that I can share with you guys. Maybe until that time, thank you, and I'll catch you in the next tutorial.